Hello once again, everyone. I've decided that I'm not going to correct the homework from the last lesson. A lot of the homework questions from the last lesson were just answering different types of surveying and sampling techniques. And the answers are in the answer key for the textbook. So I'm going to let you go and look at those answers yourselves. And I think we're just going to get into today's lesson right away. So today's lesson is about how do you display data in the best way. And usually what we do in mathematics is we display data or data as a graph. So we're going to look at some types of graphs that you've probably seen before but haven't seen in a little while for specific types of this kind of information. So the two types of graphs that I'd like to look at are bar graphs and circle graphs. So when do we use bar graphs and circle graphs? Well, they're often used to represent what we call categorical data, or data that fall under certain categories like color, birth months, etc. So here are some examples of both kinds of graphs. So if you take a look at these are just generic pictures. They don't necessarily have all of the information that should go on them. They tell you in this one, for example, that you should have a graph title, and they tell you, that a stat should go here. They tell you that that's 34% of the circle, but they don't tell you what this side of the circle is. Now, you don't have to, because you should be able to calculate that. The full circle is 100%, so 100% minus 34 would give you this side, okay? But usually you would show the percentages. This is a slightly different circle graph, which is made a little bit prettier by making it three-dimensional. But normally circle graphs look like this, and you'll have some information around the outside showing what does each slice of the pie represent, and maybe even the percentage of each slice of the pie. Bar graphs, again, this is just a nice looking one made in 3D, but usually they're flat like this, and you'll have your categories at the bottom, and then you'll have your heights. And your heights can be percentages or they can be numbers, and we'll see that in a minute. So there are two types of data that we usually work with. There's continuous data that's made up of numbers. So for instance, if I was asking you to calculate the heights of students in a class, these are numbers that are continuous, meaning that you can have students that are, if we measured in centimeters, you can have students that are 170.5 centimeters. You can have students that are 168 centimeters in height. So you can actually have heights that range from between any number, including some decimal values attached to those numbers. Or you can have discrete data or data. Sorry, I do data. Alternatively, it doesn't really matter. So forgive me for not following the same convention each time. So with discrete information, we're talking about countable data here. So this is usually quantities that shouldn't be divided, and there are different values like that. Like if you were counting the number of oranges on a table, usually you count full oranges. If you're counting the number of people in a room, you usually can't have half of a person, number of sheep, number of animals. So there are certain quantities that shouldn't be divided, and those are called discrete data. So what we're going to do is I'd like to actually show you how could you graph information using technology. So we're going to go over to Spreadsheet. And spreadsheets are fantastic for helping us organize information, but they can actually help us to graph things as well. So for this first example here, what kind of graph should we use to represent this information? So we've got some expenses and we've got some amounts, and basically these are the expenses that you might have if you're living on your own, okay? And I mean, you can do stuff in a spreadsheet, like you can center information to make it look a little bit nicer. You can actually put a grid around the information if you want to have it look nicer. So there's a lot of things you can do on a spreadsheet to organize information and make it look presentable, okay? So let's say we wanted to create a bar graph of this information. So what you can do is you can select the numbers that you want to represent in the bar graph. You can go over here to Insert Chart. So if we click on Insert Chart, now well, you know what? Why don't we start looking at a pie chart first? So in this, what happened here is the spreadsheet decided to use a pie chart to represent this information. Because it's only one set of data, it kind of said, well, this is probably best described as a pie chart. And we can see that the biggest slice of the pie, which is clothing here, you can see that clothing is the biggest number, is going to have the biggest slice of the pie. Now, you can actually double click right in the graph and change the title if you want. So let's say I wanted it to be a little bit more specific. I might change it to amount for expenses. Okay. And you can, adjust the size of the fonts if you'd like. All of that information is controlled over in this part of the window. Okay. You can customize your chart. So it is saying that it's a pie chart. You can put a hole in the middle if you'd like. So here's where you could put the labels for the slices. Okay. I'm not going to show all of that stuff. There are tutorials online that can help you figure that out. I mainly wanted to show you that you can just generate a chart very easily. So if we go to this setup here, this is where we can choose what kind of chart we wanted. So let's say instead of a pie chart, I wanted to have a bar graph instead. So if I click on this, they give me some information about the type of charts that I want. So these are the ones that are suggested, and you've got a sideways bar chart, or you've got a vertical bar chart, which is the kind that we're usually used to seeing. Okay, and again, you can probably put labels at the bottom. I'm going to let you discover that on your own if you ever need this. Like I said, there are tutorials online, but you can see how much quicker this is to do than to just do it by hand. Had we been in class, I might have gotten you to do at least one of them by hand, but you really don't need to with technology anymore. So that's one kind of graph. Another kind of graph, if we're looking at the heights of students, is we can use what's called a histogram to represent data. Now this is what we call one variable data. There's only one number here that we're looking at. And sometimes when you have one number that you're looking at, a histogram is a really nice way to do things, because a histogram will group up the numbers into ranges. So let's say all the students that are between like 150 and 160 centimeters, how many students are between 160 and 170 centimeters. So doing that by hand, it can be done, but it's a little bit tedious, especially depending on how many numbers you have, and we have quite a few here. But I just want to show you how quickly we can create a histogram. So I'm going to select all of the numbers here. You know what? I'm going to select the title too. I just want to see what happens when I do that. So I'm going to select all of this column of numbers, and I'm going to go back over to the insert chart. And it actually chose histogram for me because it said that that's probably the best solution for one variable data. Okay. If it hadn't chosen histogram, I could have gone over here. Histogram's a little bit hard to find. It's a little bit further down. It's on the other section right here for histogram. And I'm using Google Sheets here if I didn't already mention that. But it chose it for us. And the reason I wanted to choose the title is because I don't think if I hadn't chosen the title, and I'm actually going to test this out, I don't think it would have written the title by itself because it wouldn't have known that that was the title for that chart. So just for fun, I'm going to erase this chart and I'm going to just select the numbers and press on Insert Chart. Oh, okay, well, I'm surprised. It actually did figure out that the cell right above is the title for this, which is really cool. So very simple to do with technology. You just need to know how to input the numbers, which is simple, and you can input letters as well. It makes me wonder if I had chosen all of this. So let me delete this chart. If I select the whole chart and press Insert Chart, I wonder if it'll actually, oh, and it does. Look at that. It actually labeled the values. That is amazing. I wonder if it'll do it for the bar chart too. Yep, look at that. That is amazing. I didn't even know that. So I just discovered something new with you today. So that is, wow, impressive. Okay? So you can really make your life a lot easier if you have to graph things by using a spreadsheet. Let's go back to the note here. So I've just shown you how to use technology to graph information. There are probably people yelling at me online if they're watching this saying, hey, you can select the whole thing and get the titles to show up. Anyway, so let's look at what we can do to interpret information. So this is out of your textbook, and it says, Colleen surveyed the students at her school about their favorite sports. She chose a bar graph to display her results. Use the bar graph to answer each question. So whenever you look at a graph, it's always a good idea to look at what is the title of the graph, so it's favorite sport, and what are the labels along each axis. So the x-axis is sport, and you can see that all the different sports are named, and it says frequency, which means how many of each person selected that as their favorite sport. Okay, so frequency just is like a tally that we saw the other day. So which sport is the most popular? Well, you can easily see that by looking at the chart, the bar that's the highest, and this is what I meant by displaying data in a graph is usually the best way to do it because it's very easy to see which bar is the highest. So it definitely looks like hockey is the most popular. Let me just do one thing here. So it looks like hockey is the most popular. I think I just locked that in place too. Which sport is the least popular? Well, the least popular would be the lowest one, which would be golf. Does your answer to part B mean that students do not like this sport, and explain? So that's an interesting question, and this is where we need to use a little bit of logic to try to figure out stuff. What's the issue with golf? Well, golf basically is a single player sport, first of all, and you need to be pretty good at it. Not everybody has the opportunity to play golf. A lot more people, and frankly, more people I think are exposed to hockey, especially in Canada where we are, than golf. It is getting more popular, so I'm actually, like, this book is a little bit older, so this bar is probably higher at this point. But there are many reasons. There's just less people probably that are good enough at that sport to really enjoy it. And more people have been, especially in Canada, have been introduced to hockey a lot sooner. Okay, so I'm not going to write an answer to C. I think my verbal answer is good enough. Then it says, how many students said that volleyball was their favorite sport? Well, volleyball is here. Okay, so we have to measure how high the volleyball bar is to be able to answer that. Well, looking at the scale's going up by 5s, and it certainly looks like the height of volleyball is right between 10 and 20, which would make that answer 15. And how many students participated in Colleen's survey overall? So to figure that out, we'd have to add up all of the numbers in the chart. So what is the height of each one of the bars? So we've got 20, and we've got 35, and we've got 15, and we've got, now for the hockey bar is somewhere between 40 and 45. I'm going to say that it's and we have to estimate here, we don't have a choice, but I'm going to say it's not quite in the middle. So I'm going to say it's probably about 42. And golf, same thing. It doesn't quite get to 10. I'm going to say that's about 8. And the last one is just above the line for 25. So I'm going to say that's about 26. And estimation, I mean, everybody should get something close to that. So as long as it's within that range, I'd be okay with that. And then you just add all of those up, which I'm going to let you do. Okay, it's not difficult to do. Just take a calculator and add those up. You might actually be able to even do this in your head. So that would be how many students participated. So it's really a nice way of organizing the information to be able to clearly see, you know, what's the highest, what's the lowest. And calculating the total is a little bit more tedious, but it's still doable with little effort. So let's look at another one. So this one, if we look, even without reading the question, patients' masses, mass, and frequency. So this graph has to do with how we would say how heavy a person is, and patients probably represents that it's medical in nature. Okay, so the histogram shows the masses of a sample of patients at a hospital. So how many patients have a mass of at least 85 kilograms but less than 90? So 80 mass as a kilogram value is right here, and 90 is there. So they want between 85, which would be this one and this one. So they're looking at the height of this bar, and that bar goes up to a height, and if you can look at the scale again, that's a height of 13. So there'd be 13 of them. How many patients have a mass of at least 100 kilograms? So at least 100 kilograms, so here's 100 kilograms, that means anything greater than 100 kilograms, okay? So that would be both of these bars. Both of those bars that are height of 2, so that would be 4 people in total. How many patients are in this sample in total? So to do that, we'd have to actually add all of the bars together to find out all of the heights. Just give me a second here. I believe I have that answer already. So if we actually add up all of those heights together, and you could do this on your own, but I'll just give the final answer. So the total is equal to 79. And this is out of your textbook. That's where I'm getting this information. So what they're asking next is find the percent of patients who have a mass of at least 100 kilograms. So the reason we needed that total is because to find a percentage, we need to divide by the total, okay? So in question B, we had already said that there were 4 patients that had a mass of at least 100 kilograms. So if I'm looking for the percent of patients who have a mass of at least 100 kilograms for D, we're going to do 4 divided by the total, which is 79, and then multiply that answer by 100 to get our percentage. And if you do that, you're going to get 5.1%. So there is some math we can do with these bar charts of finding percentages of different values. So that's actually going to be it for today's lesson. I'm going to be giving you some homework questions from the textbook. This is in section 3.3 or chapter 3, and I'll put that on the Google Classroom. And it's going to ask you to potentially do some analyses like we did here of the different bar charts and pie charts and stuff. Once again, if you have any questions when you're doing that, information from the homework, please email me and let me know. And if you have to do any of graphs in the homework, please use Google Sheets to do it. And just practice entering the data there and seeing if you can get the right kind of graphs to display. Okay, that's it for today, folks. Have a great day.